let's start today. Okay, let me just. So welcome to Princeton MCA summer math camp summer camp. So today we'll just be going over like algebra, like linear equations and all that stuff. Okay, so yeah, let's start. So let's go. Can you guys see what I'm writing? Can you guys see that? If you just type in the chat if the color is okay and everything like that. Right? Oh, nice. You guys can see that? Nice. Okay. So let's start. Okay. So first we'll just start off with like what is okay. First I'll just start off with like who I am. So I am Sambu, and I've been doing math competitions since like seventh grade, and I think I am pretty experienced, at least in the AMCA, algebra, geometry, counting, and number theory. So this whole week, this full week, we will go through all the four subjects, and I hope this course equips you with all the knowledge you need to know to successfully take the exam. So yeah, without further ado, let's just get started. So first, we'll do linear equations with two variables. So there are there are generally two ways to solve the system of equations. So one famous method is elimination and or eliminating, yeah, same thing. Or there's another one called substitution. Uh, to yeah, tuition. So we let's look at substitution first. So substitution like requires you to isolate a certain variable from each equation and find their value. For example, okay, I think rather than like saying words, we should do stuff with examples. So take the equation x plus y equals 4 and 2x plus y equals 7. So when you want to substitute, right? So we're trying to find the value of say x, and then substitute the value of x into this equation. So from the first equation, you can get that. So from the first equation, let's call this equation 1 and call this equation 2. From 1, so from 1, you can get that x equals 4 minus y, right? Because you're subtracting y on both sides. And then you can plug this value of x into equation 2 to get 2 times 4 minus y plus y equals 7. And then this is nothing but simple algebra that most of you know how to solve. So that's just minus 2y plus y equals 7, or 8 minus y equals 7, or y equals 1. And then once you get y equal to 1, you can plug that back into x right here and get x is equal to 4 minus 1, which is 3. So you can solve the system like this. Or you could also solve for y when, like right here, instead of doing x to the 4 minus y, you could do y equals 4 minus x and substitute in the second equation and do. So that's basically a gist of the substitution method. And elimination is a little bit, in my opinion, nicer. So let's look at that. So we have x plus y. Let's take this example. Okay, x plus y equal to 3, and x minus y equal to 1. So now we want to eliminate a variable, and conveniently we see these two, right? When you add the two equations up, the y terms cancel out. So let's actually do that. Let's add these two equations up. You get 2x, the plus y minus y cancel out, and you get that equal to 4. So dividing by 2, you get x equal to 2. And once you get x equal to 2, you can plug that back into any of these equations, and then you get that y equals 1. So that is the elimination method. Does everyone get that? Now, there are other methods of doing this. So there are other methods of doing this also. Like suppose let's take a let me just get some space. Give me a second. Uh, let me. I don't want to erase it. Okay, let me just work right here. Let's just I'll just draw another line right here. Let's call this other methods. So some other methods include give me 1 second. So one of the methods could be this one. There's no like official name for it, but yeah, there's no official like name for this method. So let me just let's just call it. I don't know. It comes in linear algebra, so I can show you that though. So this is a nice method, but it's not that like prominent in other textbooks. So one method would be like, so if you have let me come up with an example. Okay, let's just do general. Okay, so if I have ax plus by equal to some value c, and then mx plus ny equal to p, then you could do that. You could say that, so by some formula which we will prove, x equals nc minus bp over na minus mb. Like, this is not required for you to know, but just it's just like a nice way to like understand it. And we can call this like the cross method, because what essentially you're doing is you're taking the cross right here, nc cross and bp cross, and you're subtracting them, and then you're taking the na cross, and then you're taking the MB cross and subtracting them. So technically, you're just making two pairs of crosses, and the first cross comes in the numerator for x, and the second cross comes in the denominator for x. So that is what, how you can find the value of x. And then similarly as the other methods, you could substitute it back into one of these two equations and then solve for y. So that's, we'll just call it the cross method, because we're taking two crosses. Yeah. So does this make sense to everybody? Does that make sense? All right, nice. So now let's go for example. I'll just give you guys like a minute to solve this problem, and then we can go over the solution. And just type in chat when you guys have finished, or unmute. Either is fine. All right, you guys have any ideas on how to approach this, at least, but like not just solve it? Yeah, I'll give you guys a hint. Try elimination method. All right, let's go over the solution. So the key to this problem, right? As I said, is let's try the elimination method. So we want to eliminate some variable, and we see, okay, we have an x, a y, and an xy term, and the xy term is a bit hard to work with when we first see. So, and then we also see, okay, this is 2x plus 2y, and we have x and y. So this motivates us, at least it motivates me, to multiply the first equation by 2, this whole equation by 2. So by doing that, we get 2x plus 2y plus 6xy equal to 10. And we can keep the second equation as it is, as 2x plus 2y plus 4xy equal to 8. Now does anyone see how to solve it from here? Okay, so from here, all you need to know, you can just see that, oh, if I subtract these two equations, that means the 2x cancel out, because when you do 2x minus 2x, that's 0. So that's 0. And then the 2y's also cancel out, because 2y minus 2y is 0. And then you get that 6xy minus 4xy equals plus 2xy. And that's equal to 2. So you know that x plus xy, my bad, not x plus y, equal to 1, because you divide by 2 on both sides. So this is not that helpful, but we realize that when we substitute this back into this equation right here, because we can plug it back in to that, you get 2x plus 2y plus 4 equals 8. So therefore, you know that 2x plus 2y equals 8 minus 4, which is 4. And then you can divide everything by 2, and you get x plus y equals 2. Now, this is also a bit hard to work with algebraically, but if you realize something, this is really easy. So if you realize that x2 is nothing but 1 plus 1 and 1 is nothing but 1 times 1, you get that x equal to 1 and y equal to 1 is a valid solution. Now, there may be other solutions that we might be missing, like suppose fractions or something, but I would say there are none, because so imagine this, you're pulling y down by some value and increasing x by some value. So when they sum up to 2, you get that. Okay, or let's just go through this algebraically. So you get xy term. Where else do you see an xy term? You see it when you square x plus y whole square, and that is a common thing that you should know, like x plus y squared, x minus y squared, and x squared minus y squared. We will cover those stuff tomorrow as part of the factorizations, but just know that for now. So x plus y squared is nothing but x plus y times x plus y, right? That's, after all, that's the definition of a square. And then we can multiply this out. So that's x squared plus xy, which is coming from here, plus xy coming from here, plus y squared. So that's nothing but x squared plus y squared plus 2xy, right? And then you know that this is equal to 1 because no, sorry, this is equal to 4 because this value right here equals 2. So you know that x squared, sorry, this is pretty cramped, just 2xy equal to 4. And you know that xy is 1 from here, like right here. So you know that x squared plus y squared equals 2. And then from here, you want to find a way to solve this problem. How are you going to solve that? You realize that, okay, what if I do x minus y squared? X minus y squared is nothing but x minus y times x minus y. And that is nothing but x squared minus xy. Again, you get another minus xy, and you get plus y squared. So you get x squared minus 2xy plus y squared. And you know something. You know that x squared plus y squared equals to 2. So you know that this plus this value equals 2. And you know that xy equal to 1 from here. So that is nothing but, so you got x minus y equals 0, right? Because you know that this computes to 0. How? Because like you get x squared plus y squared equals to 2 minus 2 times 1, which is 0. So you get x minus y squared equal to 0, or otherwise x minus y equal to 0. So now you have x minus y equal to 0, and clearly um, when you add these two equations up, you get 2x equal to 2 or x equal to 1, and y also equals 1. So what we assumed right here is correct. So does everyone understand that method? This is just an example problem that we did. Everyone get that? All right, good. All right, so now let's just look at a few word problems. Word problems are not much different than what we just did. It just requires you reading the words and then translating them into equations. So just let's look at this problem right over here. So it says a princess has 20 suitors, with some of which beg to marry her 3 times a day, and some which beg to marry 5 times a day. And if each day the princess has 78 marriage requests, how many suitors beg her to marry 3 times? So another, like, this is just a strategy I'm telling you. You should like underline the important stuff. Like, for example, in this problem, right? One of the important points is that she has 20 suitors. Some of them which beg to marry 3 times a day and 5 times a day. So that's an important point. And another important point is she has a total of 78. And the question is asking how many marry 3 times a day. So I've underlined all the important stuff. So when you're solving that problem, you can always look back and it catches your eye saying that, okay, this is really important. So, okay, let's just translate this into equations. So let's say the number of people who ask her to marry 3 times a day, let's call that value x. Okay? And let's say the people who ask her to marry 5 times a day, let's call that y. So we know that the total number of people that ask her to marry is 20 people, right? So you know that x plus y equals 20. And then you also know that each day she has 78 marriage requests. So you know that x people ask her 3 times, so it's 3 times x. And then five y people ask her 5 times a day. So that's 5 times y. That's equal to 78. The question is asking basically find x, because that's what you want to find. Mary back 3 times a day. So I'll give you guys a minute to solve this problem, and let's see if we can go from there. All right, so let's just go over the solution for this. So again, one could use both substitution and elimination methods. I personally prefer elimination, but we'll do both to get a comprehensive understanding of both methods. So first, let's do the elimination method. Let's say elimination method. So how would I eliminate variable? So I realized that, okay, what if I multiply the first equation right here by 5? That way the y's cancel out, right? So let's do that. So multiplying the first equation by 5, we get 5x plus 5y. You go to 20 times 5, which is 100. And you get 3x plus 5y. That's the second equation untouched. That's 78. Let me make this neat. So now we realize that if we subtract these two equations, the 5y's cancel out. So that's nothing but 2x equals, I believe that's 12, uh, 22. Yeah, yeah, should be 22, yes. So dividing by 2, you get x equal to 11. And you can plug that back in to the first equation because it's usually simpler right now. And you get that y equals but you actually don't even need to find y because that's okay. That's an important point also, right? The question asks you to find x, and we already found x, so there's no point wasting time to find y. So just you can say the answer is 11 and move on to test. So that's a strategy also that I forgot. And then let's do the other method, substitution. So we can substitute the value of y in this variable. Why? So again, let's keep our eye on the ball. We want to find x. So if I can get this equation in terms of x, I'm good. How do I get it in terms of x? Well, okay, the first term is already in terms of x, so I don't need to touch that. I need to get the second variable in terms of x. So for that, I need to express y in terms of x. How do I express y in terms of x? I use this equation, the first equation right here, and I can express y in terms of x. So using that first equation, you get y equals 20 minus x. You're just subtracting x on both sides. And then you can substitute that into the second equation. So you get 3x plus 5, 20 minus x equal to 78. Does this make sense? Yeah. Because all I'm doing is plugging, instead of this y right here, I am plugging in 20 minus x for that. And then it's just basic algebra after this. It's just 3x plus 100 minus 5x equal to 78. And you get, subtracting 78, you get 22 on this side. And then you can add back in 2x to both sides, and you get 2x. And similarly, x equals 11 again. And so that matches. And just for the practice, we can also do the cross method because people may find it easier. And let's revisit the cross method. So this is the cross method. So we have these two equations, and that the first cross is NC BP minus BP over NA, which is like this, over MB. So let's look at that. So in our equation, what is NC? That's nothing but, so we want to find x. So let's call this cross method, right? Want to find x. To find x, let me make a point right here. We know we have to do NC. And NC right here is like this. So that's nothing but 1 times 78. And then we want to do minus BP, which is like this, which is minus 100, right? 5 times 20 is 100. You divide it by I believe it was it was Na again. So yeah, so it was minus like this, which is 1 times 5, right? So that's 1 times 5 right here. And then we have minus like this. We have minus 3 like this. So therefore we should be getting, oh wait, I made a mistake right here. It should be the other way around, my bad. It should be this one first and then this one, my bad. It should be 100 minus 70, yeah, minus 1 times 78. So therefore, we should get 22 over 2 again equal to 11. And sure enough, we did 3 different methods and we got the same answer 3 times. So we know that's the right answer. Does everyone understand the cross method with substitution and elimination? Also, if you want me to slow down, just type in the chat. I do understand that I might be going fast. Right, let's move on. So here's another example problem that I'll give you a minute or two to try, and then we can talk over it together. All right, let's look at this problem. So again, let's underline the important stuff. So they say Andrea is 3 times as old as Jim. When Jim was twice as old, and and when, so there's supposed to be a comma here, my point. And when Jim was twice as old as he was, the sum of the ages was 47. So they see if Andrea is 29 years older than Jim, what is the sum of the ages now? So they say, okay, this is a bit of thing to digest. So when they say Jim was twice as old as he was when the sum of the ages was 47. So let's go back all the way into the past. Okay? So let's say the sum of the ages was X and, or let's say J and A. A being Andrea's age and J being Jim's age a long time ago. So you know that A plus J, right from the equation, is 47. And then they're also saying that Andrea is 3 times as old as Jim when Jim was twice as old as he was. So right now, Andrea's age is 3 times of 2J. And does this make sense? So this is like the key crux of the problem. Why is it the key crux? Because they say Andrea is 3 times as old as Jim when Jim was twice as old as he was when their ages was sum. So we go from this point in time. So we have that point in time that the ages are A and J respectively. That's 47. And then now we're talking twice as old. Andrea is 3 times as old as twice as old Jim. Okay, it's pretty hard to say that. Yeah, as long as logic makes sense, that's good. So this is nothing but 6J. And they also say uh, now Andrea is 29 years older than Jim. So J plus 29. This is, call it now, okay? So first we want to solve for A and J. So at this point, right? So let's look at this. We can substitute, here substitution is much easier. So we don't want to do elimination. We can substitute we can substitute this equation right here into this. Or yeah, this is a bit messy of a problem, but sure, we can do that. So J plus 29 equal to 6J. So you got 29 equal to 6 minus 5J, which is 5J. And then you get 29 over 5 equals J. At that point at time. Like when it was, oh wait, I made a mistake. My bad, sorry. Because this is now, my bad. You can't substitute that. You had to use these two equations, my bad. So you first get that you can substitute this value right in here. So you get 6j plus j equals 47, or 7j equals 47, or j equals 47 over 7 years old. And then now you know that Andrea is 20. Now you know that Andrea is 47 over 7 plus 29. So whatever those values sum up to, you add them up and that's it. I don't want to go through the computation because it's a messy problem. But yeah, it's not. But as long as you understand the concept, that's fine. Does everyone understand this? All right, let's. All right, now we will look at the slope-intercept form, or sorry, the equation of a line. Rather, okay, this is also an important thing. So there's like two sides to this. You should know how to write the things algebraically, and you should also know how to solve the problems graphically. So we will consider both. So the slope-intercept form is probably what you've seen in like all the textbooks. That's just y equals mx plus b. So m is the slope. So if you guys are not familiar with what slope is, so slope is nothing but the steepness of a line. Okay, to say you want to quantify how steep a line is. So slope. So say for example this line, right? The slope of this line is how much it rises. So the graph rises. Say you have 2 points. Let's say point. This is hard to see. Let's take this color. You have point x comma y right here, and you have some point right here. Let's call it a comma b. So it rises by some value, and that value is nothing but the difference in the y coordinates, which is so that's y minus b, and then it runs by some other value, which is nothing but x minus a, the difference in the x coordinate. So the slope is nothing but the rise, which is y over yb, or x minus a. So you can just think of slope as rise over run. Okay, so that's basically all slope is. It just quantifies how steep a line is, and that is measured. That is known as m right here. And then b is nothing but the y-intercept. So if you look at it, right, the y-intercept is when the line hits the y-axis in the coordinate graph. So that's the y-intercept. So this is the y-intercept. So that's basically how it works. And let's see how to graph a line in such a form. Okay, so I will just erase this for the point time being. Okay, we'll just take a numerical example and then run through it. So suppose we want to construct a line between say 3 comma 5 and I don't know 6 comma 10, right? So we want to construct a line. Let's do that. So we first draw our graph. Let's this is the x-axis. So it's 1, 2, 3, 4, 5, 6. We don't want to go above that, and we want to go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it goes all the way up here. So let me just erase these points. I'll write them right here. 3 comma 5 and 6 comma 10. So we want to plot the point between 3 comma 5, which is right over here, and we have another point 6 comma 10 all the way over here, and we want to draw this line. Let's draw that. So first, let's try to find the slope of this line. And like I said, slope is nothing but rise over run. So you have 2 points right here, right? So what's the rise? The rise is nothing but the difference in the y coordinates. Well, the y coordinate at this point is 6 comma 10, so that's 10. Right here, that's the y coordinate. And this point is 3 comma 5. So the y coordinate is 5. The difference is nothing but 10 minus 5, or 5. Then the run is nothing but the difference in the x coordinates. So here the x coordinate is 6, and here the x coordinate is 3. So 6 minus 3 is nothing but 3. So slope is nothing but rise over run, or 5 over 3. So that's the slope. So that's nothing but the m value. And the y-intercept is now what we want to find. So now is where things get a bit tricky. So we know that y equals 5 over 3 x plus b. So this we want to find this b right now. So how do we do that? Okay, so we know that anytime you input a value of x, you get a value of y back. So we realize that okay, if I input 3, if I input this coordinate, into this equation, we should get the correct value, and we can solve for b theoretically because we know the value of y, we know the value of x, so it's just we want to solve for b, and we can definitely do that. So let's substitute x equal to 3 and y equal to 5, because that's the this point right here, that and that will base the equation of line because it lies on that line, right? So any point lying on that line will base the equation, so you can always plug it back in. That's 5 over 3 plus b. So the three threes cancel out. So clearly b equals 0. And my graph doesn't look accurate enough because it's not drawn to scale, but theoretically the graph should be somewhat like this, going through the origin because it goes through 0, and that's the y-intercept. So the equation of this line would be y equals 5 over 3x plus 0, or nothing but 5 over 3x. So that's nothing. That's how you find the equation of a line using slope intercept form. And yeah, so does that make sense? All right, so now let's look at point slope form. So point slope form is like another way of expressing the same equation of a line. It's not much different. So except yeah, it's not much different. All you want to do is you're given a single point the line passes through. Okay, so let's call that point, for example, say x0 comma y0. Let's call that's the point, and the zero doesn't matter. Okay, or rather, let's call it a comma b. So that's the point a comma b, and we want to find the equation of that line, given that this line passes through that point a comma b. So that would be y minus b equal to m, which is again the slope, x minus a. So that is the equation of that line. And we can like try graphing it with an example. So let's go back to the same example. Let's say some random line that we want to know passes through 3 comma 5, and say the given has a slope of 5 over 3 for simplicity. Okay, the slope is 5 over 3, and we want to find what's the equation of this line. Okay, so we can draw our graph again. I don't want to label the coordinates again. It's good enough if we, let's just say this is 3 and let's call this 5. So this is a point, and we have some line with slope 5 over 3 passing through it. So how do I find the equation of the line? I can just plug this into this equation. So you know that y minus, so you got the y coordinate, which is b, which is 5, equal to the slope, which is 5 over 3, times x minus 3. And we can, this is the equation of that line. And if you expand this and solve it, you should theoretically get this value, and we can confirm that. So you get 5 over 3x, just expanding this side, minus 5, and then that is equal to y minus 5. So we know that y equals 5 over 3x minus 5 plus 5, because you're just adding plus 5 to both sides right here. And these things cancel, and clearly y equals nothing but uh, 5 over 3x. Sorry, yeah, 5 over 3x. So that should say that, okay, so the equation with slope 5 over 3 passing through this point has to be the equation of the line as y equal to 5 over 3x. Does that make sense? So that's basically the graphing aspect and the other the solving aspect of the equation of the line. I think these are the most two common known ones, and there are probably others like x plus y equal to something, but yeah, it's all the same thing. You can always just move things around and work with it. But yeah, just know these two well enough. All right. So now that we started graphing, I also would like to talk about absolute value. This is probably not an often touched topic, but it's still useful to know for many people. So let's start with the definition of absolute value. So absolute value is like represented so by like this. Okay, so that is nothing but absolute value of a. So so basically geometrically, right? Absolute value just looks at the distance from 0 to any point. So take a point A, right? Absolute value looks at this distance. Take a point negative A, uh, absolute value looks at this distance. So this is exactly why absolute value is never negative, because it's always looking at the distance from 0 on the number line. So this is always, always, always like non-negative, or rather from 0 on positive numbers only. You can never have a negative number. So that said a notation form that would say like absolute value of 5 equals 5, because the distance between 0 and 5 is 5, and the absolute value of negative 5 is nothing but 5, because the distance between 0 and negative 5 is also 5, right? So now let's think about this. What if we have some equation saying that absolute of x minus 5 equals 7? How do we solve this equation? So we can take a step back and realize, okay, this is pretty hard to work with. So let's just say this is a. So absolute value of a equals to 7. All I'm doing is just substituting a equals x minus 5. This is a perfectly normal technique that you can use in these problems, because it makes it simpler and it makes it much more digestible for you to understand. So if absolute value of a equal to 7, you know that a has to be either 7 or negative 7, right? Because if you want a distance from 7 from 0, you know it has to either reach 7 right here or negative 7. So that comes to say absolute value of any number a would equal to sorry, absolute value, yeah. If I say absolute value of some random number equal to x, right? So if I say absolute value of a equal to x, the possible values of a is x and negative x. Or some people also write as plus minus x like this. So you should also know that. You can always have a plus or a minus for an absolute value. So you get a equal to x7 or negative 7. And you can substitute back a as x minus 5. So you get x minus 5 equal to 7, or x minus 5 equals negative 7. And now you can solve both of these equations for x. The first one is simple to solve because you just need to add 5 on both sides, right? So you get x equal to 7 plus 5, which is 12. Or the second equation, you can add 5 to both sides, and you get x equal to negative 2. So the values of x satisfying this equation right here are x equal to 12 and x equal to negative 2. So that's basically how you solve most absolute value problems. Does that make sense? Just understand the geometric aspect of what absolute value is. And once you understand that, I think any absolute value problem can just be formulated from that step. As long as you know the distance from 0 on the number line, you can make sense of it anytime, anywhere. So let's just look at one practice problem for absolute value. Yeah. So the question is asking which of the following equation does not, oh, that's not, let me not use what, does not have a solution. So again, I underlined it because it says does not, and that's a key thing to know. So it does not have a solution. Let's say, so let's go through answer by answer. You know that x plus 7 squared equals 0. A square can always be equal to 0, right? Because 0 squared is 0, and you know any square is always 0. So this doesn't seem to be the answer because this does work. So then you look at this. I say, okay, what do I get? Absolute value of negative 3x equals negative 5 because I subtract 5 on both sides. But we just said that absolute value can never be negative, right? Because it's a distance from 0. So this is not even possible. You can never have anything which is negative. Absolute value of anything can never be negative. So therefore B is the answer. Does that make sense? Yeah, good. So that's basically the absolute value. And then we also would look at absolute value graphs because that's also like this is a more advanced concept rather than AMC8 or math counts. But if you know this, I think it's better for most people to know it. So let's go back to our equation from here. X minus 5, absolute value of x minus 5. So sorry, let me use white again because white is easy to see. So we got y equal to x minus 5. We want to graph this. How are we supposed to graph this? So one way to do this is that you can memorize that the absolute value function looks like a v, like this. So this is nothing but this is the equation of y equal to absolute value of x. So that starts at 0 and 1 it comes at 1. At negative 1 it follows at this point. It's the same point. So at 2 it comes back at 2, and at negative 2 also it's at 2. So if I were to outline it, right, this would be like right here and like right here. So each of those points would correlate to that. And this also makes sense because think about it. So absolute value tells you the distance between that number x and the origin. So and that is represented on the y-axis because that's what the function y is. So when I input a value x, it should give me the same value y in the negative and the positive side. So it's one line like this and another line which is just flipped over the y-axis like this. So that's the absolute value of y minus x. Sorry, absolute value of absolute. Sorry, y equals absolute value of x. Sorry. So now we want to graph this equation. How are we supposed to do that? Okay, let's draw our coordinate grid again. So it's 1, 2. Let's just do it for sake of keeping it, or rather, let me make a better coordinate system. Let's do something like this: 1, 2, 3, 4, 5, 6, 7, 8, and then yeah, this axis we will determine later. So y equal to x minus 5. So how I start with these problems, which I do not know how to graph, is plugging in some values of x. So let's try to plug in, I don't know, x equal to 0. What do we get? We get absolute value y, when you say 0, so you get 0 minus 5, which is absolute value of negative 5, and that's nothing but 5, right? So 0 goes all the way up here, and you can call this 5, right? 4, 3, 2, 1, 0, right? So now let's plug in 1. Okay, so 1 minus 5 equals negative 4, absolute value of negative 4, and that's nothing but 4. Okay, so 1 correlates to this point. And let's plug in absolute value of 2. Now let's plug in x equals to 2. So absolute value of 2 minus 5 equals negative 3. Absolute value of negative 3 is nothing but 3. So we can plug it in right here. And similarly, when you plug in 3, you get 2, and plug in 4, you get 1. And when you plug in 5, you get 0, because absolute value of 0 is nothing but 0. And when you plug in 6, you get 1 again, because 6 minus 5 is 1. Absolute value of 1 is always 1. And 7 becomes 2. So it starts going back up. So really, the graph looks like this, sort of a line like this. So V, so basically it's a V centered at 5 instead of 0. And that's basically how you graph absolute x minus 5. And if it had a coefficient in the front, like say 2, right? All you're going to do is multiply each of these inputs, these outputs by 2. So that would just be a scrunched up V like this, instead of a V which is expanded, where this point, let's use red, where this point 3 is corresponding to 2, right? It would just correspond to 4 rather. So it would be something like this. Does that make sense? That's basically how you graph absolute values. Yeah. So this is a bit of an advanced concept, but you should, I think it's easy to understand at this level, and it can be like really useful for you when you go into like higher levels of competition. So yeah, let's go on. If you guys want, you can take like a 3 minute break because I know it's been a lot, and then we can attempt the example problems. I have 5 example problems right here, and then we can start. Yeah, so you guys can either try this or take a break for 3 minutes and then come back. Right. So does anyone want to type the chat how they solve this problem? Like So we can like have a group discussion rather than just me talking and just going over the problem. All right. Okay, no problem. So yeah. All right, let's just go over the solution because we're running out of time. So they say the taxi fare in Gotham City is 240 for the first one half of a mile, and an additional mileage every mile you run after that. It costs 0.20 cents for each additional point 1 mile. Okay. So the driver, you plan to give the driver a tip of $2. So how many miles can you ride for $10? So the question is, how many miles can you ride for $10? So and then each additional mileage is okay. So you got this. Okay. So basically, you have to pay no matter what. You got to pay 240. That's the baseline, and you got to pay the $2 tip. So basically, at the front, without any extra additional mileage, you're paying the driver 440, right? 440. And they're asking you how many can you ride in $10. So let's see how much money you have left. So you have 1000 minus 4.400. So that's nothing but 0, 6, and 5. So you have $5.60 left, and you wanna push it. Oh, wait, let me extend the call by just a few more minutes because it says. All right. So you have to extend. Okay, so you have to get $5.60. So so now you get 0.20 cents, or sorry, not point 20 cents every time you write point 1 mile. So you want to see how many 20 cents can I add to get $5.60? Well, you notice that five 20-cent coins, right? Five 20-cent coins gives you $1. So you know that to get $5, you need to do 25 25 20-cent coins, right? Because you're just multiplying this by 5 to get multiply this by 5, right? And you can get this to be 20-cent coins. So 25 20-cent coins to get $5. And then you want to get three extra coins, right? Because you want to get three extra coins to get of 20-cent coins to get 0.60 cents. So when you add these all up, you should get $5.60. So therefore, you're taking 28 extra coins of 20 cents. And 28 extra coins gives you zero point 0.1 mile each. So you get 28 times zero point 0.1 mile for those number of miles. So that is nothing but you should get, so 1.1 is nothing but 1 over 10. So 28 over 10, which is nothing but 2.8 miles extra. So then you also have to add in your first one half a mile, right? To find the total number of miles. So this 2.8 miles you have traveled already by adding 28 20-cent coins. And then you're giving the one half mile for the first $2.40. So you know that one half is nothing but 0.5, right? And then this is 2.8. So you can add them up. You get $3.3. So sorry, not 3. What am I saying by that? 3.3 miles. So the total trip is nothing but 3.3 miles. And yeah, does that make sense? And as you can see, this problem was, I guess, somewhat of a algebra problem. It's more rather logic than algebra. So you should expect these type of problems on the AMCA also. You really can't prepare for these type of problems. You just got to use your intuition and logic and try solving these type of problems. So yeah, let's look at example 2. Also, since we're running out of time, I'll just walk you through them. And with the recorded lecture, you can go back and pause the video and try again. So this is an AMC 12 problem, so it might be a little bit more difficult. So you have x minus 2 equals p. So that's what they're given. And they're given that x is less than 2. So that's something to remember. And they want you to find what is x minus p. So again, when x minus 2 is p, so you know absolute value of, so let's call this x minus 2 some value a. So you know absolute value of a equals to p. So a is equal to either p or negative p. So we can substitute back x minus 2 into this. So x minus 2 equal to p or negative p. So you can add back 2 to both of them. You get x equal to p plus 2 or x equal to negative p plus 2. Now you got to notice something right here, okay? So we know p is always positive, and this gives that x is less than 2. So when I add a positive number plus 2, it's always going to be greater than 2. So this value is always going to be greater than 2. So this can never be the answer. So this has to be the answer, and that's basically the problem. And I think the answer options gave like x minus p plus 2 and all that stuff. So this should be the right answer. So yeah, let's look at example 3 now. So this is a math counts problem. So they give that a b c and then plus d c a. I mean, not write it, so it's done writing it. So they give this equal to 100, and they say a b c and represent the digit numbers. And they all say they are distinct values. So this is also a key word that many contests use to trick people. Always when you see the distinct means like they're all different. So just always like extra underline that, because I've fallen into many traps of not reading that distinct and getting the problem wrong. So how do we go about solving this problem? So if I think you guys should have learned that at the digit number ABC, at the digit number is nothing but 100A plus 10B plus C, right? This makes sense because think about it. If I say 353, that's nothing but, how do you beat it? You said 353, right? So that's nothing but 353. So you add these all up, you get 353. So that's the same logic here. Or rather, the place value thing, I think you guys learned this a while ago. So that's 3 times 100, which is 300, 5 times 10, which is 50, and then 3 times 1, which is 3. So you know ABC, the number ABC equals 100A plus 10B plus C. And similar, the number DCA, right, equals 100D plus 10C plus A. And they say that when you add these all up together, right, you get 1,000. So 1,000 you get equals to you get 101A because you have 100A and a 1A right here. And you got 10B, you got 11C, and you got 100D. So you want to find for what values of A, B, C, and D meet the value of 1,000. Now this is a bit hard to work with, right? I mean, it's not really easy for us to see. So how I would go about doing this, I would realize that, okay, you know that when you add C and A, right? Because when you write this as A, B, C, and you get D, C, A, you get 1,000 like this. This is nothing but how you do addition, right? So you know that C plus A gives you a 0, and you get a carryover of 1 because when you get a 10, right? That's the only way you can get 0. Or it could be C and this be 0, C and A be 0, but they say distinct value. So C and A can never be 0. So that means they have to sum up to 10. So C plus A sum up to 10, you get a 0. So you have a carryover of 1. So you know that B plus C sums up to 9. Let me just write that down. C plus A has to sum up to 10, and B plus C has to sum up to 9 because there's a carryover of 1. And then it's a 10 again, so you put a 1 here. So A plus D also has to sum up, sorry, A plus D, my bad, also has to sum up to a 9 because 1 plus 9 gives you the 10. So this is something we ought to keep in our mind when we are trying to approach this problem. So let's try to see if any values here work nicely. So let's just say, I don't know, for the sake of it, let's just say C equal to 3. So A must equal to 7. So if A equal to 7 right here, B must equal to 2, right? And if D equals to 2, okay, that doesn't matter. And we have C equal to 3 right here. So B must equal to 6. So clearly they're all distinct. And surely if we check it, so let's try it. So A is 7, B was 6, C was 3. And then we have D is 2, C is 3 again, and A is 7. Let's add these up. Let's see if we get 1,000. So we got 10, 1. So that's 6 plus 3, which is 9, plus 1 is 10. We add 1. 7 plus 2 is 9, plus 1, that's 10. And clearly we do get 1,000. And this is not just, I just chose a random number 3. For example, you could choose a random number 4, and you could also still work. So basically all that tells you is this value A plus B plus C plus D is always going to be constant. So it doesn't matter what value of c you choose, as long as you come up with some value that works, that that satisfies these equations, you should get a good answer. In our case, I just chose three out of the random. For example, I could have chosen, if you guys wanna further proof, I could have chosen, say, I don't know, even one for C, so that means A has to be 9. So if A is 9, then D has to be 0. Okay, yeah, Z has to be 0. But this is not good because they say two-digit number, like right over here. So we don't want to choose 1, right? Okay, that was my bad. I should have seen that before we started. My bad. Let's say we choose, I don't know, 5, because why not? So this is 5. We know that A cannot be 5 again, so we can't choose 5 either. Let's say we chose 6. So A has to be 4. That works. So then if this is A is 4, that means D has to be 5. And then B, C is 6 right here. So B has to be 3. And clearly, if we do ABC, which is 4, B was, I believe, 3, and C, I believe, was 6, plus D, which was 5, C, which was 6, and A, which was 4. When you add these up, we get 1,000 again. So this is 1,000. So there are multiple answers that you could do. So I just chose one out of the random. So we want to do 7. So the answer should be 7 plus, so 6. That's A was 7, B was 6, and yeah.